Sup guys. So in the previous video we were talking about salt preparation. We know that salts could be soluble or insoluble. We know that the insoluble salts are definitely made by the ionic precipitation method, and the soluble salts could be made by one of the two methods. So the very last video was largely about the titration method, in which we used to mix an alkali with an acid, and we talked about the whole process of it. And then we saw that in titration method we use an alkali, which is either lithium hydroxide, sodium hydroxide, potassium hydroxide, or ammonium hydroxide, and we titrate it with an acid. The acid goes into the conical flask, you add indicator with it, then you titrate it with the suitable alkali depending on the salt you need, and then once the titration is done you repeat it, but this time without the indicator. Then you get the salt solution, which you heat until the saturation point, then it gets cooled, you get the crystals, and then you dry them using a filter paper. In today's video we're going to be talking about the acid plus excess insoluble base method. There's no specific name for this method, just the acid, which is the required acid no matter whichever acid you use, and the excess insoluble base. Now the insoluble base means insoluble metal oxide, because metal oxides are basic in nature and they are also insoluble in water. So you could be using any insoluble base, from calcium oxide, magnesium oxide, aluminium oxide, you can be using zinc oxide, you could be using iron oxide, lead oxide, copper oxide, or silver oxide. All these oxides are metal oxides, they are basic in nature and insoluble. And then you have any acid of your choice. You can have any acid depending on the salt. So right now we are talking about a general preparation method, and we'll see how we do it. So no matter whichever acid you use, you take a conical flask. This is your conical flask over here. We are labeling it again that this is your conical flask, and you add whatever acid you need. For example, you want to make, let's suppose, calcium chloride. Then for the chloride, you know, hydrochloric acid is the most suitable choice. If you want to make a nitrate salt, then nitric acid should be there. If you want to make a sulfate, you use sulfuric acid, right? Then you add, within the conical flask, you add 25.0 centimeter cube of acid, whichever acid you want to use, hydrochloric acid, sulfuric acid, nitric acid. Once you have it, then what you do is you take your conical flask and then you add excess insoluble base. Now you could be adding any metal oxide over here. So once the step 1 is done, you have your acid over here. Let's suppose I'm using some blue liquid for that. Let's suppose you have your acid over here. Let's label it that we have required acid, and let's call it 25.0 centimeter cube of the required acid within the conical flask. So in step 1 you add the acid, in step 2 you have the acid over here, but then you add your excess insoluble base. I'm using a silver pen to show the spatula, which is generally the case. I'm using a spatula to transfer, for example, any metal oxide. Let's suppose I'm talking about iron oxide, which is green in color. Let's suppose you could be adding any metal oxide over here. So you add your metal oxide. This is your spatula and this is your metal oxide. So you use a spatula to add excess metal oxide, or you can say the excess insoluble base. Excess means that you are adding it in extra, you are adding it more than required. Then what you do is, once you have your excess insoluble base over here and the acid was already there, you heat the conical flask along with the contents, so just the mixing is proper and that you obviously get your salt made in less time. So you have your excess insoluble base and stuff and everything is right over here. You're gonna heat it. So you have your tripod stand, you will have your Bunsen burner over here. You'll supply heat from the bottom. So in the third step, you heat and stir the solution to obtain the salt. Once the salt solution is made, what you do is you have to remove the excess or the unused insoluble base. So what you do is, within your conical flask, you have your salt, but this time you have some extra insoluble base over here. So let's suppose purple color is the salt solution. Let's suppose hypothetically the purple solution is the salt solution, but you have some insoluble base remaining over here. Let's recall this. This is the salt solution, but this is the insoluble base. Salt solution, but unused excess insoluble base, which is obviously the metal oxide. So this is the excess unused insoluble base over here. You have to remove that. How do you do it? You filter it. So here you will filter the solution to remove the excess insoluble base. So what we're going to do in the step 4 is we filter out the excess insoluble base. You obviously use a filter paper for that. Make sure you talk about it. Make sure you mention that you are using a filter funnel. Make sure you're using a beaker to collect it. Make sure you're using the fact that you're using a filter paper for that. So you have your solution over here. Remember, the purple colored solution was right over here. So you're transmitting your solution along with the excess insoluble base. You had it over here. You're going to collect it on the filter paper. This is your filter funnel. Over here you have a filter paper. What you're passing down is the filtrate. So your filtrate is the soluble salt solution, and what you have on the residue is the excess insoluble base. So you have the filtrate and you have the residue. Residue is the insoluble part, so residue is going to be the excess insoluble base. And what about the filtrate? Filtrate is the salt solution. Make sure you talk about filtration, and along with that you also mention adding of water, which is distilled water. So you also mention wash with distilled water. So while you're performing the filtration, you add a small amount of distilled water so that the filtration continuously goes on. So far what we have done is we took acid into the conical flask, we added the excess insoluble base, we heated and stirred them for the proper mixing, the salt solution was prepared, then we filtered out the insoluble base and we washed it with distilled water, and now we have the salt within the solution. How do we filter it? How do we get the salt from the solution? So in the last step, or perhaps the second last step, you heat your salt solution. So you're going to heat your salt solution over here. This is your salt solution. You put it on a tripod stand. You have a Bunsen burner. This is your china dish. You're going to supply heat. So in that step number 5, you're going to heat the filtrate to saturation point, and then you cool it for the crystallization. Then cool for crystallization to obtain the crystals. And once you get the crystals, because the water keeps on evaporating, the water evaporates but the salt crystals remain. Then you get a filter paper. So you're gonna get a filter paper over here. Let's suppose this color seems fine to have a filter paper. You get your filter paper, and then you get your salt. Let's suppose these are the crystals of the salt. So you collect them on a piece of filter paper. It's a filter paper. You collect your crystals on a filter paper, and then you dry it within the filter paper using the folds of the filter paper. So in step 6, you dry the crystals using a clean filter paper. So these are the steps of the insoluble salts. Let's recall it. We use excess insoluble base, which is the metal oxide, and we add acid of our choice. So first acid goes, then you add the excess insoluble base, then you heat and stir the mixture for salt solution formation. Then you get the salt solution, but some amount of the insoluble base is still remaining. You filter it out. The filter process requires filter paper, obviously. Then once the filtration is done, you wash it with distilled water. Then the filtrate, which is the clean solution, includes the salt and water. So you crystallize it using the saturation point heating, and then you cool it for crystallization, and then finally the crystals appear that you dry within the folds of filter paper. This process goes on when you have an acid and you have excess insoluble base, and obviously when you don't have an alkali to go on with. So let's keep this process in mind, and next video we'll be talking largely about the equations. So I hope this video was clear for us, guys. Thank you.